Pen's looking later these days, but that happens when you record lectures too. I'll just have to assume everybody's catching up on lectures. So, anybody have questions before we get started? We're going to talk about a few security concerns today. Yep.
Like when you are making these templates, you just like parse the entire page that you.
When you're making what?
Like when you're trying to put stuff into a HTML template, just like read the entire HTML that was like what exists there already and rewrite it.
Well, you would read your template and then replace.
Yeah.
I mean, we can talk after class though. That's a specific question. But you read your whole HTML template and then look for your placeholders and replace them with your content. But you would read that whole file. All right. And I do have the lecture channel open, a reminder. I have that open too. Yes? Yes. Is that only for file uploads? Or is it doing that with your text uploads as well, your text form? There's a few things that can cause that. So the question is, on the server, printing out the request, it's only printing out the headers and not printing out the body. This sometimes happens depending on your browser. Sometimes the browsers will send just the headers and then the body later. So when you read from your TCP socket, that's saying, whenever there's data available, give it to me. So as soon as those headers hit the TCP socket, your method returns and gives you that data. So you might have to go back to that and say, do all your parsing and say, look, I didn't get all my information, and then call, have a conditional. If I don't have all the information I need, I didn't read content length number of bytes, then read from that socket again and see if that extra information is there. Or even, and you can test this, you can do a quick and dirty hack to test this. Just call that twice. Call it once, print to the screen, and then call it again and print to the screen. See if you get your entire message that way. If that prints out everything, then your browser's just sending this piecemeal. If that's not the issue, we can talk more and I can try to help. All right, anything else? I like getting questions. I would much rather have a lot of questions than everybody be confused on the homeworks, for sure. Though office hours are pretty light too, so maybe you're all just up to speed on everything. All right. Let's get into some content. So we're going to talk about two security concerns today. One where users can get arbitrary files off of your server, which of course is bad. And then one where users can inject any arbitrary HTML into your other users' machines, which is obviously bad. These are two huge security concerns. As we're getting into more dangerous territory, these security concerns are going to be important. And on the homework, whenever there's a security, I'll put them in red, a security concern. If you haven't addressed that concern, it's going to be a 0 on that objective. Security concerns should be our foremost concern as web developers. You can have the best app, the most beautiful app with all the bells and whistles and all kinds of great features and everything. If it has a security hole, you've just done your users a much larger disservice than anything you've done to help them. You can't have a security vulnerability if it's going to be like leaking your users' information, which is the biggest thing that we have to protect. Users are trusting us with their information. We have a responsibility to protect that information. So if we have a security vulnerability, that's terrible. That app is much, much worse than a really crappy app, which is practicing good security and has good security and is airtight and not leaking any data. And whenever we have these vulnerabilities, whenever a vulnerability is hit on like a major company, it's always making the news. You don't want to make the news. You don't want to be working for one of these companies and be the dev responsible for millions of social security numbers being leaked, credit card numbers being leaked. You don't want to be on the news for that reason. Something we have to take seriously. So if you aren't taking these seriously, it's going to at the least be a 0 on that objective. For the project, you have security holes. It could be up to a 0 on the entire project. We have to take these seriously. Whenever we have a security concern, I'll highlight it in lecture. If you have a security vulnerability that I haven't highlighted in lecture, you're not gonna be on the hook for that if I haven't even talked about it. I don't expect you to go research everything on your own and patch every security vulnerability. But the ones I talk about in class, you can't have these vulnerabilities. Absolutely no. And these are the most common ones that are easy to make mistakes with. So we're hosting files now. And you're hosting files that can't be hard-coded. So for homework 1, there were 8 images. You could just hard-code the paths for each image and say, you can only request these 8 images. But now we're in a different situation where users can upload files, and then we're saving those files to our hard drive, and then users can request those files. But since we don't know which files will be uploaded or how many files will be uploaded, we can't hard-code these paths the way we could get away with in homework 1. So we have to have some path that's going to host the images, and it's up to you to decide how to form that path. It's one of the first paths where I just say, like for the image names, I don't say what you have to name those images and how you have to serve those images, but you'll have some image path, and you're probably going to have some way in that image path. Oops, I do specify, don't I? I don't specify the image names, though. But you're going to have some path that's going to take a file name, or at least part of a file name, and you're going to serve that file. So no matter what your solution looks like for that, for naming images and hosting images, you're going to have that feature somewhere where one path can host multiple images which don't exist when the server initially starts. So if we have a path like this, like image/file name, which you'll have, and you'll have some code that says extract the file name, open a file with that name, and send it to the user. Well, what happens when a user requests this? Instead of requesting an image that exists on your server, they're going to say, wait, I can just grab any image I want off, or any file I want off of the server, and the server is just going to read the file and send me the bytes contained in that file. So what if they asked for your private SSH key? Are you going to send them your private SSH key? Yeah. I mean, well, that's the default folder where your SSH keys. Like if you have SSH keys, they're on your laptop right now, they're probably in this folder. They're probably right there in this file ID RSA. You can override that, but that's the default. That's where you're going to find them. The squiggle goes to your home directory. So we're going to navigating to the home directory, entering the hidden SSH directory. A dot is the first character of a directory name, is hidden directories. Entering that directory and then accessing the ID RSA file, which is your private RSA, your private SSH key. So what if somebody requests that? You're going to honor that request and just throw that into your code and say, open the file with that name and send them whatever they want. And of course, this is just an example, one of the most devious examples, but they could just request potentially anything, any file on your hard drive, any file on your server's hard drive. What if they're getting database keys and then starting to log in remotely to your database, getting all your data? Like once you have this vulnerability, it's up to the hackers to be creative and probably compromise everything. Probably gain access to your system. Maybe they'll get your SSH. Well, they would have your private key. They'd probably be able to do it already, but maybe your SSH passwords as well, and just log into the machine after this attack and be able to just recover anything. Bad things. So this is something we need to address if your app is vulnerable to just arbitrary file retrieval. This is going to be obviously a security hole, but luckily it's not that hard to defend against. If you don't allow certain characters, they're not going to be able to do anything with that. For this class, for your homework 2, 3, and 4, if you just don't allow slashes, that's going to do everything you need it to do. It's a little bit limiting because you can have subdirectories in your images directory or any static files that you're serving, but that's a sure way to ensure that you're not going to have this attack. Without the slash character, I put a bit of thought in this. Without that slash character, I'm sure a very sophisticated hacker could still get around that with other characters. Without the slash character, there's no obvious security hole. And by the way, when I'm talking about zeros on the project and objectives, that's if you have an obvious security hole. It's not, I'm looking at it and going, well, technically I could hack this. It's, holy crap, you're vulnerable to even the sloppiest, most incompetent hacker could get into this thing. If you have one of those security holes, that's where I'm pulling out the zeros, by the way. If it's a technically they could hack it, we're not going that crazy. For the zeros anyway. But if you remove all slashes, so if you get that file name, do a find and replace on slashes and replace them with empty strings, and then read the file, you're going to be good, in my book anyway, in my eyes. But if you're not escaping that slash, and I can request tilde slash index.html, oh, that's a bad example, but server.py, and I can get your server code, that's bad news. And that's really it for this. Now you could have a list of all the valid files and make sure it's one of those. If you want to go that far, absolutely do that as well. So whenever somebody uploads an image, whatever image name that has, store that in a data structure or database. We haven't really talked about databases yet, but store it in a data structure. And when you get a request, look up that data structure and say, is what they're requesting in this list of valid file names? If not, don't respect this request. If it is, respect the request. If it's not, give them that 400. Some 400 level response, maybe a forbidden, maybe a 404, but whatever you want to give them to say, hey, you can't do that. It's not a file on my, probably a 404 in this case. You don't want to assume they're being malicious. You give them a 404 and say, that file doesn't exist on the server. And don't forget to disable your mime type sniffing. We did this already on homework 1. I think I might have forgot to add them to the objectives in homework 2, the testing procedures. But don't forget to disable your mime type sniffing. If it's not in the testing procedures, it won't affect your grade. Unfortunately, I should have had them on there. I just thought of it now. No, when I was talking to the TAs, I thought of it, but it was already too late. The assignment was out. But anyway, disabling mime type sniffing is extremely important now. Before, you were hosting your own files. We were just doing that to make sure your MIME types were correct. But now it's critically important, because what if instead of a file, somebody uploads JavaScript, and then your server is hosting JavaScript to all of your users, and then your users download this JavaScript. The browser says, this isn't image/PNG or image/JPEG. This is JavaScript. I'm going to treat it as such. And then your browser runs this malicious JavaScript on everybody's machines. So this is critically important now that we're handling user content. Once we're handling user content, all of the security concerns start blowing up. Yeah. I don't know. I don't know. It's a good question. So the question, when is mime sniffing ever useful? I don't know. If the devs don't know what they're doing, I guess. It's really not, in my opinion. It's pretty standard practice to disable it on all requests. You can go search the internet. You'll see that no sniff on most requests on most sites. It's pretty standard practice these days. So the browsers, they're, bless the devs and everything. They're trying to help us out there, but this is one that just opens up too many security holes. We don't like it. All right. Any questions on this? Recursion is illegal. All right. Our next big one. This is a devastating attack. The file paths, somebody would really have to be trying and looking for that. Well, I guess the same is true here. But this is something that people will look for a lot. Like whenever I have an example site live in lecture, students will look for this attack, like all the time. People look for this one. You have to protect against this because, everybody who knows a little bit about web dev can potentially attack you with this one, which includes all of you. HTML injection attack. So now we used to have static sites in homework 1. We were just serving content. It was all hard-coded. It was HTML, CSS, JavaScript, images. Everything was controlled by your server. Your server controlled exactly what content was going to be sent to the users. But now that's not true. Now that we have a dynamic site for homework 2, that's not true anymore. We're handling user content. We're handling the image uploads. We just talked a little bit about that. We're also handling their text. And I want to talk about their text inputs here. So we have text that users are sending to us, stored on the server, which isn't that scary, storing on the server. But then the scary part is we're taking that text and sending it to all of our users, and all of our users are rendering that text on their browsers. Basic chat app functionality. That's the feature we want. We want that to exist. That has to happen. But what can our users send us that we might not like? Well, lots of things, but we're going to talk about one specifically. So you're handling user data. Whenever you're handling user data, whenever you're handling user requests, any HTTP requests, never trust that content. If you get nothing else out of the security portions of this class, get this, at least understand this. Never, ever trust your users. I've harped on this a bit already. When we went out to the internet and started breaking sites and writing browser extensions and going into the console, all of your users can do that. They can modify anything they want on your front end. You can't have any front end security. And realistically, never trust your front end, the front end of your site. Never trust the front end, anything the user gets to touch. Don't trust any of it. Yes, you can trust most of your users, but guess who else has access to your app? Everybody has access to your app. Once it's out there on the internet, everyone with an internet connection can access your site. It's not just your precious users. Maybe all your standard users are fantastic. You have a great community, or you're building a great brand and everything with those users, but everybody has access to that. Every single person with an internet connection. So if everybody has access to that, anyone who wants to be malicious is going to send you that malicious stuff. Yeah.
So, should you not make API requests from your server, from your front end? Should you just serve them from your back end?
You can send the API request from, that's standard.
You're exposing your API endpoints to your users.
Yeah, you expose your API endpoints, and then you don't trust the requests, but your API just does your API things. You still don't trust anything on your API. Never trust your users. Never trust your users unless you have an API. Never trust your users.
So there's every API technically public because you can just.
Yeah. You can write code right now that accesses an API, or you can go to your browser and access it. You go to Postman and access it. You can hit any API out there. Most APIs, you'll have to register for an API token or OAuth or something. So they have some level of accountability, because they're not just going to open it up. There was a glorious day of the internet where APIs were just open, and you could just access a lot of different APIs. They're very rare to find now. APIs are really locked down. You need the tokens so they can track you. They can disable your account. They're not just going to disable an IP address if a certain IP is sending a bunch of requests. They want accountability with the token. So there's at least accountability, but they still are not going to trust you. They're just going to do all their verification, do all their checks, and once you're doing something they don't like, something nasty, then they say, hey, it looks like you're trying to hack us. We're revoking this token. And they can do things like that. But they're absolutely not trusting their users with an API. And you might think, well, my little old app, who's going to attack my little app? There's no group of Russian hackers sitting in a cloudy, smoky room going, we're going to get that 312 project, we're going to do it. Probably not. But what they do have are bots that just scan IP addresses and look for common vulnerabilities. I had a site, I had a Q&A site for 115 once upon a time. It was an open source project. I deployed it on a UB server. And the students could ask questions and answers in kind of a Stack Overflow format. It was an open source project, so the UI wasn't quite as good and stuff, but it worked for our purposes. It was nice. I just use Piazza these days, but I noticed I started. I had the first class. I'm like, hey, this Q&A site, blah blah blah, go register. And then like a week or two later, I'm like, I wonder how many people registered, and it was like 4,000 people. I'm like, whoa, these students are really getting into Q&A. They even spread it with people outside of the class. This is fantastic. And then it started to grow to like tens of thousands. And I'm like, okay, something's up. So I looked into who they were, and it was just clearly randomly generated email addresses, just bots spamming the hell out of my account, out of my server, just creating accounts. Luckily, I had email verification active, so they couldn't make any posts, but they were still creating accounts and attempting to make some posts on there. But yeah, they must have been scanning for that specific open source project, finding it, accessing the forums, creating accounts, and just trying to do whatever they could, probably just to advertise their stuff. I actually found out later their profiles were public. They actually did get away with some stuff, so I shut this thing down. Their profiles were public, and inside the profile for their accounts, they would put links to whatever websites they wanted. And then they would use that to boost their SEO because they had links from my server to their server. So they would start rising up the search rankings. So as soon as I realized that was what's happening, shut that down immediately. But anyway, everyone is looking, bots included. Doesn't have to be some big site with tens of thousands of users or more. The bots are going to find you. You have those vulnerabilities. Those bots can find you. Yes.
So in that example, with the bots making a bunch of accounts, how would we protect against something like that?
I mean, in this class, I'm not going to be concerned about it, but how would you in general? I added a CAPTCHA, which shut them down. They still tried. They still sent the requests, but the CAPTCHA, they couldn't get past that. So that stopped everything. But that's why you see CAPTCHAs everywhere. It's pretty much our only reliable line of defense for now, until the bots get smart enough to, AI gets smart enough to, handle those. Then, I don't know, we'll move to the next line of defense. It's always a back and forth game when it comes to security. It's always each side just trying to get one step ahead of the other side. So right now, CAPTCHAs are in the lead, but we'll see what happens tomorrow. So everyone has access to your site, which is what we want. I mean, you want everybody with an internet connection having access to your site. That's the beauty of the internet. So we're not just going to restrict everybody. We're not going to restrict this, but we got to be aware of this and know that anybody can be looking for our site. So great, everybody has access, but what are they going to do? Post mean things? Are they going to post links and boost their SEO? I mean, those are fairly harmless. But one thing they can do is start adding HTML into your, I shouldn't say harmless, but it's just not what I want to talk about today. What they can do is send HTML into your chat app. So if they start typing HTML in your chat app, and we're storing that HTML and then sending that HTML to all of our users, well, now they can effectively edit our page, and not in a way that we did earlier where, I just edited my copy of the page. Now they can start editing the page for all of the users because they're using our server, sending that data to our server, and we're sending their attack stuff, their HTML, to all of our users. Now everybody has that change. Now things get scary. So great, they can make their text larger, they can put headers, whatever. The scary one is when they start typing JavaScript. Script is an HTML tag, it's an HTML element, and then they can write whatever JavaScript they want. And that can run on everybody's site, and that gets scary. So now that they're running whatever JavaScript they want on every user's computer, well, now it's whatever JavaScript they can write. Maybe they'll try to steal some cookies, which we have protections on the cookie side for this too. But maybe they can steal some cookies, steal some private data, make requests on their behalf. Maybe they can have all users spam the chat. Maybe they can have all users spam a different site They can start sending requests to different sites, maybe even trying to steal cookies from other sites, taking advantage of login tokens, authentication tokens. It's whatever JavaScript they want to write. If you're vulnerable to JavaScript injection, we call it HTML injection, but the real scary part is when they use HTML to inject JavaScript. So once they start injecting JavaScript, it's, again, up to the attacker's creativity of what they can do there, but they can do a lot of damage. This is even stronger than it's like installing an extension into your browser for that site, but it's even stronger than that because it's running in the same environment as that site. So it has access to all of the variables and objects within that site's environment, whereas an extension runs in an isolated environment and can only access the DOM, all the HTML elements. Well, this is going to run in that environment and have access to all of the JavaScript of that site. So there's a lot of damage that can be done here. So we have to protect against this. Yes, yes. Yeah. Yeah, whenever you're taking a string, I mean, in that case, it would only be attacking themselves. So, I mean, who cares really? But yeah, they could. It should be percent encoded though, because those are special characters. But potentially, yeah. So how are we going to prevent against this? Again, luckily, it's not too difficult. It's pretty straightforward to protect against this. It is an easy thing to forget, and oh my, the embarrassment when I have a lecture example where I make a site live to the whole class and I forget. Oh my goodness. It's easy to forget. I know from bad experiences. Hopefully I don't make those mistakes anymore. But ampersand, less than, and greater than, if you don't allow any of these three characters, you can't write any HTML. Try writing any valid HTML without any of these three characters. You can't make tags, which is really the essence of HTML. Then the ampersand, I forget off the top of my head why ampersand. I think just so they can't have escaped characters like we're doing. But just take away less than. I would have a tough time writing any valid HTML without a less than symbol. So escape these three characters. Some libraries will want to escape quotes as well, just for extra, just extra comfort. I don't know what they could do with quotes without these three characters. But if we escape these three characters, we're good. So HTML, remember way back when we were talking about HTML, has some specially named characters. Now we can do ampersand and then the byte code for any UTF-8 string or any UTF-8 character. But there are special named ones. Ampersand, less than, and greater than are three named characters. So ampersand, amp, semicolon, LT, and GT. These are the escaped characters, the escaped versions of these characters. So when the browser finds any of these strings in something that it's going to render these as those characters and not interpret it and parse it as HTML. So since these aren't going to be handled as HTML, it can be able to inject any HTML, but the regular users are still going to be able to see what they're supposed to see. Yeah? Yes. Yeah, the semicolon says, I'm done escaping a character. So I'm starting to escape a character, I'm done escaping that character, and everything in between is the character that you want. Yeah, the semicolons have to be there. Then the browser just treats those as text. Problem solved. All right, so let's see a demo of that. All right, so I have a web server. I'm just going to run it. I'll scroll through some of this code. I want to go over, since we're on homework 2, I want to go over some of the homework 1 stuff. So I'll show you a few things of how I have things set up. Just in case somebody's falling behind, I want to help you get up to speed so you're ready for homework 2. But oh my goodness, I swear I just ran this. What does that even mean? Token not found for the Scala compiler? I knew I shouldn't have stopped. It was running when I got to class. And I'm like, well, I'll stop it so they can watch me fire up the server. Should have just left it running. Goodness. Okay, let's go into debug mode real quick here. Move that. Franco's.
I looked it up. It says to uninstall the Scala plugin and then
Oh
restart
boy.
the IDE and then install it back in.
Oh, I don't really want to do that. It wants to update. Hopefully the update will just fix it. I mean, that'll
That should
effectively, yeah. Yeah, because I have to restart anyway. I'm going to get hungry looking at that. Huh?
Are we gonna mess with Franklin's site?
No. Maybe we can get some free pizza? Oh, maybe we'll leave Franco's alone.
Small businesses that-
because we have dollars.
Oh, yeah. That's a victim of
Yeah, I wouldn't feel bad about that. Like 10 free people. They can survive.
Index. Oh, I don't have to wait for it to index. We can try this. So anyway, I can start explaining it though. Here's my code that's going to escape my HTML. Now, in practice, you'll use libraries for this, but the libraries usually just do this, plus usually quotes too. But I'm not doing this, and I'm literally just replacing the characters with their escape characters. And make sure you do ampersand first. Don't do that last, because it'll escape these ampersands, and you'll get not exactly what you want. So I'm not doing that right now, so I'm running this server. It's a simple chat box. Nothing interesting. Nothing too interesting. Well, I don't know. I think it's interesting because we get to see how websites work. But it's not necessarily a site that you would want to visit. So I'm going to type in the chat, hello. We can do this in a different, what's up? I got two different users, random usernames, just an anonymous chat. And then somebody gets smart and says, I'm going to add, a horizontal rule here. I want my text to be enormous. We can type any HTML we want here. And we can type things like script. Let's try to get a little bit of an attack here. Nothing too devious. Close my script tag. I get no IDE support inside this text box. Send that. And then even when another user reloads the page, they should, if I... Oh, no. Script. No, I want to get this. Alert. Used all the right syntax there. Script. Maybe I spelled something wrong. Oh, come on. Just alert should work though. Anyway, well, I ran that JavaScript on there. We didn't get the... All right, we got a few minutes. Do I have my syntax wrong? Oh well. Well, you have to trust me. That JavaScript's running. I don't know. I might be missing an attribute. I don't know. I don't know what I'm missing there. I feel like that should work. But that is injected. That code is part of the page. We'll at least do it this way to verify that JavaScript is there. It is part of the HTML, and it should be running. But that is rendered on any user who visits this page. They're going to get that JavaScript executed. It's going to run. I guess I can try window.alert. Nah, I don't want to spend too much time on this. Yeah, well, I have it in this tab because it should go. It doesn't always run immediately, but on a refresh it should. But even a refresh isn't doing it. All right, I don't want to mess with it too much, but that's definitely should be running that JavaScript, unless just one quick thing to check. Yeah. All right, I'm not gonna spend more time messing with it. Point is, we're vulnerable to HTML injection, which means JavaScript injection. If I was better at being malicious, we would have hacked my other tab. I just know to protect against this. I don't know what to do once I want to exploit that vulnerability. I don't really want to, but there are certainly ways. I feel like that should have worked. But now we restarted the server. I'm going to type the same thing. Oh, you're killing me. Am I just not calling this? Script alert, blah, blah. So now this is not the demo I expected to go wrong. This is the simplest one. Nothing should go wrong on this demo. Goodness. Ain't nobody. All right. Let's go to our form. Our form is sending, it's using send message, chat, send message, get that, send an AJAX request, post, send message, post, send message, clean message, chat history, append message.
I think it should replace.
Yeah, it should. It's not how I wanted this demo to go. UTF-8, print to the screen, yeah. If it's a WebSocket. Well, I'll go through the code. I'll go through the code and explain the parts I want to explain, and maybe I'll see it on the way. I don't, like, it seems like it's running an old compiled version and not taking my changes. but we'll see. So I have the way I have this organized, and way I recommend you do, at least something like this, is I have a lot of functionality in different classes. Only 4 different classes. You don't have to go overboard if you don't want to, but just separating some of the concerns in my app. And then, I have some WebSocket stuff here as well, but if it's not a WebSocket, this is what we want to read. This is some buffering stuff that I'll talk about Monday. But once I get the request for what you're doing for homework 1, homework 2, this is where you would be starting. You'd get the request. I'm calling my request class. This is a class that's going to take the bytes of the request. I'm going to take a Boolean of whether or not it has a request line. So I want to use the same code to parse the parts of a multi-part form. So I'm going to say, if this is a multi-part part, then it doesn't have a request line, and everything else is parsed exactly the same way. And then I'm going to go through this request bytes. I'm going to look for that new line as a byte string, so in bytes, find that, get everything before it, start parsing it as headers, and get my headers into a data structure, and start parsing all of my information, looking through all of this, looking for the colons, the equal signs, the semicolons, looking for all that information and extracting it from the headers, and then returning an object which is going to have the information that I'm interested in. I want to preserve the raw bytes just in case I want to look back at it. Method, path, HTTP version, all my headers, which for what it's worth, I do leave my headers as a string, and then I do, I'll split on semicolons afterwards if I have a case where I'm going to look for the extra information. So I would update this. I probably should. And then the body. We can't do anything with the body generically because that body could be anything. So once I have that request, all of that information using my helper code for a request, to parse a request, then I'm going to start looking at how to handle this. This is buffering code. And then I do have just an else if, but I like to keep my else if as clean as I can. And I do want to show an example of not using an else if later for a more complicated server. When there's a lot of else ifs, this gets gross. But even if I'm using else if, I want to keep it to one line. This is one statement, send text response, and then the arguments of that. This is using an HTML template. I have my basic template here that we saw in lecture. And then I'm giving it a key value store of the values, of the value of what I want to replace and what I want to replace it with. I want to replace description with this. I want to replace image file name with this. And then send that using my util, which is going to form the HTTP response and ship it. If I get the root, I'm going to use, and this has been caused confusion before, so I want to be very explicit here. Util.sendTextResponse is code that I've written. I'm not using a library here. This is code that I've written. Somebody was like, "Well, you use libraries in your lecture exam." No. I wrote that code. It's right, it's right over here, right here in my project. I just can't open util because there's too many solutions in it. But I'm using my code. I have generic code that's going to take the bytes of a response. It's going to take the content type, and it's going to construct the response, the HTTP response for me. It's going to calculate the content length. It's going to take this content type. It's going to set the no sniff header. It's going to handle all that. And I'm reading this file right here. I'm just sending index.html as one big string. Socket stuff, and then when I get to the end, get my, that's just socket stuff. And then send message, /send message, which I don't think we're using, get message, we're not using, getting a static file, which I shouldn't show that code. Redirect 4.4, and then where the hell is the... Am I ever calling this? I think I'm just not calling this. And buffering code. Let's send a debugger and see. Yeah, I'm never getting there. But how is it working? These are all GET requests, so all post requests go down there. The functionality is working. I don't know. I might just call this because I don't want to have you just stare at me swearing at my thing.